Okay, in this lecture we're going to talk about what happens to a polynomial at the ends. All right. In other words, when we talk about the end behavior, we're talking about what happens as x gets larger in the positive direction. All right, direction. Now what we mean by that is as x approaches infinity, okay? And what happens as x gets smaller, right, in the negative direction. Okay, in other words, x is approaching negative infinity. Now, just as a cue, let's have a look at what happens to our squared function. Here's our squared function. As x gets larger, y is getting larger in the positive direction. As x is getting smaller in the negative direction, going towards negative infinity, it's still getting larger in the positive direction. So in other words, what we have here is as x approaches infinity, y is approaching positive infinity as well. And as x is approaching negative infinity, y is approaching positive infinity still. All right, and this is because this has an even, okay, degree. Okay. All right. What if I take a look at the cubic function? Okay. Like so. This is y equals x cubed. All right. Now notice as x approaches positive infinity, it still gets larger going up this way. So y is approaching positive infinity. As x approaches negative infinity, in other words, this direction, our y values are getting larger in the negative direction. And this, of course, is because this is an odd degree. Okay, because of the power of 3. Now we want to translate this into a higher degree, all right, polynomials. And one other thing we want to mention here is to do with the multiplicity, all right, and we know that the multiplicity, all right, of a polynomial has to do with whether it actually crosses, all right, or whether it touches, okay? And if we have the multiplicity of a 0 being 0, then what we have is that it's either coming down here and cutting in this one position, or it's coming up here and cutting in this one position. This is the x-axis here. All right, and so we have that particular situation there. Now, if it has a multiplicity of 2, for example, we have that case right here. Okay, like so. All right, so keep that multiplicity in line as well as we come to graph some of the behavior of these polynomials. All right, so let's have a look here and break this up into odd degrees and even degrees. So let's have a look at an odd degree. All right, so we're talking about an odd degree polynomial. Now remember, a polynomial has this form. All right, to a3x cubed plus a squared x squared plus a1x plus a0. Right, now, for example, let's suppose I had a function, and let's just use a quadratic for now, but we had something like 3x squared minus 18x plus 7. Right, now as x gets larger, right, then this here becomes the dominating term. Because as x gets larger and larger, x squared gets even larger, and this negative 18x is not compensating for it. And so when we're considering the end behavior, we really only have to look at the leading term. Okay. Alright, so it's the leading term that is going to actually look at the dominating situation. So we're now looking at a situation then of looking at particularly the situation where I'm looking at ax to the n being the leading term and n is odd. Okay, if that's the case. Right, now if a is positive, of course, okay, then it's going to maintain the same sign as x to the n. Right, so for example, if a is positive and I'm looking at x getting larger in the positive direction, then my function is also getting larger in the positive direction. But of course, as x goes towards negative infinity, when I cube a negative number, I get a negative number, and this positive by negative will still be negative, so this means that f of x is going to go towards negative infinity. Now, if that's the case, all right, if I want to look at that, and I'll look at just a sort of axis, a virtual axis here, if you like. What's going to happen is this, right? As x gets positive, all right, towards the positive direction, that means we're moving this way, right? Then what's actually going to happen? Then, of course, our function is getting larger in the positive direction, so it's going up like this. All right, so it comes down. We don't know what it does near the middle there, but then it comes down and as it goes towards the negative. So here's x is going towards infinity this way, and here's x is going towards negative infinity in that direction. And here's our end behavior. Right here. And here's our end behavior here. Right, this is getting more negative, larger and negative. This is getting larger and positive. Okay, now what happens then if we have a is less than 0 though? And we have x is going towards infinity. Then if we're looking at this thing here, going towards infinity, this is positive, very large positive, and we're by a negative, so this means that our function is going towards negative infinity. All right, now as x approaches negative infinity, okay, then a is negative, remember, and this is going to be a large negative number by a negative number will be a large positive number. Right, so again, if we look at our sort of virtual axes here, right, as x goes towards infinity this way, notice that we have this is going towards negative infinity, so it's going down like this. Now it comes up. We don't know what it actually does at the in here, but then as x approaches negative infinity, going this direction, this is getting large positive. And so here's our end behavior here and here for this particular scenario. Right, now what if we have an even degree? Right, then we're talking about ax to the n, all right, where this is the leading term again because it dominates. And of course n is even, like squared or power of 4, power of 6, power of 8 and so forth. All right, so if that's the case, all right, as we do this, as x goes towards infinity, then remember that this is a positive number raised to a even number will be still positive, and by a positive number here, so let's take this as a is positive for our first case, then this will go to positive as well. All right, so if that's the case, then when I draw this, right, so let's suppose then it's going towards positive infinity. Right, then of course it's going up this way. Now we don't know what happens in between here, all right, but when it's going, x is going towards negative infinity this direction, then we know that it's still becoming positive, and this will be the end behavior. okay, because it's going up and going up. Okay. Now, what if we have a is less than 0? Right, then we have x is going towards negative infinity. Then we're coming here, and of course, even when this is even, this negative number to an even power will still be positive. By negative means the function will go to a negative infinity. When x is going towards positive infinity, then of course our function, right, is going to do exactly the same thing. When I have negative in, oh sorry, I did that wrong. That should be positive infinity. Sorry, that should be negative infinity. I did that right. And this should also be negative infinity because we have, watch it carefully, we have indeed x is going towards negative infinity, so we have negative in a very large negative number to an even power will be positive. By this negative number will be negative. All right. When we come here to positive infinity to an even power still positive, by this negative will give me a negative. And so when we do our virtual axes, right, this time of course as x goes towards infinity, all right, this is getting larger in the negative infinity direction. All right, we don't know what happens there, but of course it comes down, and as x goes towards negative infinity, all right, it's still going towards negative infinity. And so this is the case for an even degreed polynomial. All right, now we're going to start putting all this together next, and we're going to look at graphing, all right, the polynomials. And of course, if we look at an example of, say, let me just do a little section here. Suppose I have this particular function. All right, f of x is equal to, say, x cubed minus 2x squared minus x plus 3. Right, the thing we're interested in is this leading term. And so notice what we have here. A is equal to 1, which is positive, and n is equal to 3, which is odd. And so when I look at this, I'm looking at this case up here. We have a is positive, greater than 0, and n is odd. So we have this case here. So what's our behavior going to be? Well, it's going to be like this and like this. Okay? And this is how we determine the end behavior. Okay? And what if I had something like f of x is equal to x to the 6 plus 2x cubed minus 5. Then again, here is our leading term. Now it's even. Again, we have a is 1, which is equal to 1, which is greater than 0. But now n is equal to 6, which is even. So we're looking at this particular case down here. A is positive, n is even, so we have this kind of end behavior, and so we'll end up with something like that. So if I do that here, it'll be going up like this, and then up like this. And that's how we work out the end behavior.